Hello students, today we'll discuss algebra of continuous function. So what are the algebra of continuous functions here? So we are taking here any two functions. So those are f and g. See, like f and g are two functions. So we are taking both are the continuous function. At x is equal to a in the domain. Okay. So the first one is their sum also. So if f and g are continuous functions means even their sum also is continuous functions. Is continuous at x is equal to a. Even the second one is their subtraction. F minus g continuous also at x equal to a. The third one is their product. F into g is also continuous at x equal to a. Okay. The next fourth one is their subdivision. So f by g also is continuous on this. But here one condition is g of a should not equal to 0. Okay. Is continuous at x is equal to a. So these are the algebra of continuous functions here. Okay. So next, one of the important point, what is that means? Every polynomial function, every polynomial function is always continuous. Is always continuous for every real numbers. Okay. So only for polynomial functions. Any polynomial you can take that is always continuous function for every real number. The next second point is so every rational function also even so every rational function. So every rational function is continuous in its domain. Okay. So that is nothing but f of x is equal to one of the function. It is in the form of rational function means p of x divided by q of x function is continuous. So here numerator also is a polynomial, denominator also polynomial, and q of x is not equal to 0 here. So at these cases are the continuous functions we will get here. Okay. So next 5.1 means sixth problem you will see here. So the sixth one is what they given here. F of x is equal to 2x plus 3 if x is less than 2 and 2x minus 3 if x is greater than 2. So we have to find out discontinuity of f where f is defined by. So we have to find out only discontinuity. So where it is discontinuous. So we are taking here let k is any real number. K is any real number. If k is any real number means here total we get three cases you will get here. So the first one is case one we are taking. If k is less than 2. k is less than 2. So less than 2 means the function is 2x plus 3. So that is we are taking here LHL. So f of k is equal to. So f of k is equal to how much we will get here? So f of k is nothing but 2k plus 3 you will get here. If you substitute here, k is less than 2 means this function f of x equal to x plus 3 will get here. So f of k is equal to 2k plus 3. Even limit function also, limit extend to k, f of x is equal to. So limit extends to k, f of x is what here? We have to take here 2x plus 3, which is equal to wherever x is there, if you substitute k, 2k plus 3 will get. Therefore, limit extends to k, f of x is equal to f of k. Okay. Therefore, f of x is continuous at x is less than 2 here. So, on x is less than 2, it is continuous here. Next, the second case is what we are taking. If k is greater than 2. Okay. If k is greater than 2 means f of x will be 2x minus 3. So f of x is 2x minus 3 means f of k is equal to 2k minus 3 will be here. For this one, next we will find out limit. Limit extends to k, f of x is equal to, limit extends to k, f of x is equal to, limit extends to k, f of x is 2x minus 3. So here also if you substitute k, 2k minus 3 will get here. Therefore, limit extends to k, f of x is equal to f of k. So therefore, here also f of x is continuous at x is greater than 2 here. So greater than 2 also it is continuous. Next we have to check here at x is equal to 3. So that is third case is at k is equal to 2. Okay. So k is equal to 2 means here two cases are possible here. One is left hand limit, one is right hand limit, one is at x is equal to 2 here. So first we are taking LHL function. So LHL is limit extends to k minus f of x is equal to. So limit extends to k minus means that is less than 2. That is nothing but 2x plus 3. So 2x plus 3 is equal to 2k plus 3 will get here. Next RHL is, so RHL means limit extends to k plus f of x is equal to. So limit extends to k plus f of x is 2x minus 3. So 2x minus 3 if you substitute here 2k minus 3 will get it. So we know that here LHL is not equal to RHL. Therefore, the given function is not continuous at x is equal to 2. So at a particular point, this function is not continuous here. Okay. The next question. Seventh one. The seventh one also same as it is here. First we have to check with minus 3 less than minus 3 equal to minus 3 and greater than minus 3. Next again 3 functions there means less than 3 equal to 3 greater than 3 also we have to check here. So we are taking here also let k be real number. If k is a real number means case 1. So what is case 1? If k is less than minus 3. So k is less than minus 3 means f of x is equal to. So f of x equal to what we will get here? This is modulus x plus 3. So modulus x plus 3, k is less than minus 3 means modulus x will become minus x we will get here. So less than minus 3 means this will become minus x only. So next f of k is equal to minus k plus 3 here. Even limit extends to k, f of x is equal to. So limit extends to k, f of x is minus x plus 3, which is equal to minus k plus 3. So here also f of k is equal to limit extends to k also. Limit extends to k, f of x is equal to f of k. So this is continuous function. Okay. Therefore, f of x is continuous at x is less than minus 3. Next, second one is if k is greater than minus 3. So greater than minus 3 means we have to take here minus 2x here. So greater than minus 3 means f of x will be greater than minus, this is minus 2x here. So f of k is equal to, that is minus 2k will get here. Next limit extends to k, f of x is equal to. So limit extends to k, f of x is minus 2x, which is equal to minus 2k here. Therefore, limit extends to k, f of x is equal to f of k here. Okay. F of x is continuous at x will be, so what we are taking here, greater than minus 3. So x is greater than minus 3. So next third case is at x is equal to or k is equal to minus 3. So k is equal to minus 3 means this function. So means we have to take left hand limit and our right hand limit and we have to get here. Okay. So that is left hand limit is limit extends to k minus f of x is equal to. So limit extends to k minus f of x is. So k minus means this one minus 3 minus this is modulus x plus 3. Okay. Modulus x plus 3 means go. It will be minus 3 minus means modulus x it will be minus 3 only will get. So modulus x will become minus x plus 3 will get. So which is nothing but minus k plus 3 will get here. Okay. So k is equal to 3 we are taking means this will become minus 3 minus 3. Sorry. F of 3 limit hand function will be minus x plus 3 we have to take here minus x plus 3 where x value is 3 we have minus 3 is there. Okay. X value is minus 3 means so we have to substitute here minus of minus 3 plus 3. So plus 3 plus 3 is equal to 6 will get here. Next right hand limit also. So limit extends to k plus is nothing but minus 3 plus that is f of x is equal to limit extends to k plus so k plus means minus 3 plus that is minus 2x you will get. So minus 2 into minus 3 is equal to plus 6 you will get here. Next f of x also. So f of minus 3 also if you take here. So f of minus 3 is nothing but equal to minus 3 is minus x plus 3, which is nothing but minus of minus 3 plus 3 is equal to totally plus 6 only we get here. Therefore, f is continuous at x is equal to minus 3 here. Okay. Next case is fourth one. Next, we have to take 3 plus and 3 minus and equal to 3 also. So, x is equal to k, that is less than 3 we are taking. Okay, less than 3 means this is the function we have to take here. So, f of k is equal to minus 2k will get here. And when limit extends to k, f of x is equal to limit extends to k, f of x is, so less than 3 means minus 2x you will get here minus 2k. Therefore, f is continuous at x will be less than 3. Next, fifth one is x is equal to k, that is greater than 3. So greater than 3 means we have to take here 6x plus 2. So f of x is equal to 6x plus 2. So which means f of k is equal to 3k plus 2 here. Next, limit function, limit extends to k, f of x is equal to limit extends to k, f of x is 6x plus 2, which is nothing but, sorry, 6x plus 2 means f of k will be 6k plus 2. So this will become 6k plus 2 here. Therefore, f is continuous at x will be greater than 3 also here. Okay. So f of x is continuous at x is equal to k, which is greater than 3 here. Next, last one, at x is equal to k, which is equal to 3. So which is equal to 3 means first LHL will take here. LHL is limit extends to 3 minus f of x is equal to 3 minus means less than 3 will take here minus 2x. Minus 2x will be 3, which is nothing but minus 6 will get here. Next, RHL if you take here, RHL is greater than 3, that is 3 plus means 6x plus 2. So limit extends to 3 plus f of x is equal to, so 6x plus 2. 6 into 3 plus 2 is equal to 6. 3s are 18 plus 2 is equal to 20 here. So LHL is equal, sorry, LHL is not equal to RHL. Therefore, f of x is discontinuous at x is equal to plus 3. So only at this 3 it will be discontinuous. So remaining all the points it will be continuous only. Next, eighth one. See eighth one, f of x is equal to modulus x by x if x is not equal to 0 and 0 if x equal to 0 here. See here, so the given function is f of x is equal to, first if we take here x is not equal to 0 means x is less than 0. So less than 0 means this will become minus x. So modulus x is nothing but minus x will get, minus x by x is nothing but minus. So if x equal to 0 means already they given x equal to 0 means that value is 0. If x is greater than 0 means modulus x will become plus x only. X by x is equal to, okay, plus 1 will get here. Now we'll take here. Here also three cases you will get here. Let k be real number. Okay. If k is real number means case 1 is if x is equal to k and k will be less than 0. So less than 0 means we have to take this function here. So f of x is equal to minus 1. F of x equal to minus 1, then f of k also will get here minus 1 here. So limit extends to k, f of x is equal to, limit extends to k, f of x is minus 1, which is nothing but minus 1. Therefore, limit extends to k, f of x is equal to f of k here. Okay. So f of x is continuous at x is equal to k, which is less than 0. Next, second case is if x is equal to k, which is greater than 0. So greater than 0 also we will take here same function. So that is continuous only. So greater than 0 also we will take here minus 1. So f of x is equal to minus 1 only, which means f of k also minus 1. So limit x tends to k, f of x is equal to limit x tends to k, f of x is also minus 1, which means minus 1. Therefore, limit x tends to k, f of x is equal to f of k. Okay? Therefore, f of x is continuous at x is equal to k, which is greater than 0. So greater than 0, all the values, it is continuous function. Next, the third case is equal to 0 we have to take it. So limit x tends to k, which is equal to 0. Okay. So this is if x equal to k, which is equal to 0. So in this case, we will get here left hand limit function. So left hand limit function is limit x tends to 0 minus f of x. So 0 minus f of x is modulus x by x. So 0 minus is minus x by x. So which is nothing but minus x by x, which is nothing but minus 1 we get. So next RHL limit is limit x tends to 0 plus f of x. So which is also here also we will get here plus x by x you will get plus x by x is nothing but plus 1 will get here. Okay. Sorry, greater than 0 means we have to take here plus 1. So this will be plus 1. Here also plus 1. Plus 1 will get here. So here we will get here plus 1. Therefore, here LHL is not equal to RHL here. So therefore, f of x is discontinuous at x is equal to 0. Okay. At only x equal to 0, this function is discontinuous. The remaining cases, it will be continuous only. Okay. Next, ninth one. So same here also, x divided by modulus x if x is less than 0, minus 1 if x will be greater than or equal to 0. Okay. Given that f of x is equal to. So if x is less than 0, so less than 0 means modulus x will become minus x. So x by minus x is equal to minus 1 will get. X will get cancelled, minus 1. If x is equal to 0 means x equal to 0 means this will be minus 1. If x is greater than 0 also minus 1 only will get here. Okay. So if x is less than 0 means minus 1, equal to 0 also minus 1, greater than 0 also minus 1 only we are getting here. So in these cases, so all the cases we are getting minus 1 only means directly we can write here. So therefore, limit x tends to k, f of x is equal to f of k is equal to minus 1, where k is some real number. Okay, where k is real number. Therefore, f of x is continuous at every real number. Okay. Next, a 10th one. See 10th one. F of x is equal to x plus 1 if x is greater than or equal to 1. X square plus 1 if x is less than 1. Given that f of x is equal to x plus 1 if x is greater than or equal to 1. If x is less than 1 means we'll get here x square plus 1 here. So we are taking here let k be real number. So first we will take here the case one is if x is equal to k, k will be greater than 1. So greater than 1 means f of x is equal to, so greater than 1 is x plus 1 we will take here. So f of x is equal to x plus 1. That is f of k is equal to k plus 1 we will get here. Next limit function if you will take, limit x tends to k, f of x is equal to limit x tends to k, f of x is x plus 1, which is nothing but k plus 1 will get here. Therefore, limit x tends to k, f of x is equal to f of k will get here. Okay. Therefore, f is continuous at x is equal to k, which is greater than 1 here. Next, case 2 is, so what is case 2? We have to take less than 1. If x is equal to k, which is less than 1 here. So x is equal to k less than 1. So we'll take here f of x is equal to, so less than 1 means we have to take here x square plus 1. So f of k is equal to k square plus 1 will be here. So k square plus 1. Even limit x tends to k, f of x is equal to k square plus 1 only will be here. Therefore, limit x tends to k, f of x is equal to f of k. Therefore, f is continuous at x is equal to k, which is less than 1 here. Next, case 3 is if x is equal to k, which is equal to 0. Sorry, equal to 1. Directly 1 if you will take here, here we will get here again 3 cases. That is left hand limit. Limit extends to k. So k minus we will take here. So k minus f of x is equal to limit extends to k is nothing but 1. 1 minus. So 1 minus means less than 1. We have to take that function is x square plus 1 here. So in place of x, if you substitute 1 here, 1 square plus 1 is equal to 1 plus 1 is equal to 2 you will get here. Next, RHL limit, limit extends to k plus f of x is equal to limit extends to k is nothing but 1 plus f of x is greater than 1 means x plus 1. So x plus 1 means 1 plus 1 is equal to 2 you will get here. Next, f of x also. So f of k also if you found here, which is nothing but k is nothing but 1. F of 1 is equal to 1 means 1 plus 1 we will take here. So this is 2 here. So all the three are equal means LHL equal to RHL is equal to f of 1, which is nothing but 2 here. Therefore, f is continuous at every real number.